All right, now I want to talk about some common IFR producers. We're all kind of familiar with fog, but in aviation, we like to define everything. And so we have all kinds of different fog types. So if you see below, there's a type of fog and a description of that fog. I'm just going to go through quickly and talk about the different types of fogs. Keep in mind that you will be tested on fog types and their classifications on the written test, as well as you may be asked about them during the check ride if your area of operations is prone to fog or the type of fog that is in your area of operations is prevalent. Okay, let's jump right in. Radiation fog is one of the most common types of fog. It forms over the land when radiational cooling reduces the air temperature to or below its dew point. This generally happens at night and often clears up after sunrise. You might see this type of fog after a clear night with little to no wind. Then there is advection fog. That occurs when moist air moves over cooler surfaces, causing the air temperature to drop to its dew point. This type of fog is common along coastlines and can move inland with the wind. Unlike radiation fog, advection fog can be quite extensive and persistent even after the sunrise. Then there's upslope fog. When moist, stable air is pushed up sloping terrain, it cools adiabatically to its dew point, forming upslope fog. You'll often encounter this type of fog along the eastern slopes of the Rockies in the Appalachians. It can be quite dense and extend to high altitudes. Then there's something called frontal fog. Frontal fog forms when warm, moist air is lifted over a front and cools to its dew point. This often happens with warm fronts, but can occur with other fronts as well. It can cover large areas and persist for extended periods of time. Steam fog forms when very cold air moves over warmer air, causing the moisture from the water to evaporate and the condensation from the cold air. This type of fog is common over the lakes and streams on cold mornings and can be seen over oceans during winter. Freezing fog occurs when supercooled water droplets in fog freezes on contact with surfaces, creating a layer of ice. This can make surfaces extremely slippery and in particularly dangerous for aircraft if the ice accumulates on the airframe or the rotor blades. Next one is mountain fog or valley fog. Mountain tops can poke through the fog that forms in the valleys due to cold air drainage. This type of fog usually forms in the autumn and spring and is densest around sunrise when the temperatures are lowest. Let's talk about low stratus clouds. Low stratus clouds form a gray uniform layer that can sometimes be mistaken for fog when it is close to the ground. They usually bring light precipitation like drizzle and can obscure the sun, creating a dull, flat light. Always be cautious when flying through these clouds, as they can obscure visibility significantly. Now, let's talk about haze and smoke. Haze consists of tiny particles suspended in the air that scatter the light, giving the sky a bluish or yellowish tint depending on the background. It can drastically reduce the visibility, especially when flying towards or away from the sun. Smoke, often from fires or industrial activities, behaves similarly but can also carry toxic particles. Both haze and smoke are typically stable, and visibility within these layers can be highly variable. Let's talk about blowing restrictions to visibility. Blowing snow, dust, and sand can severely restrict visibility. Blowing snow occurs when the wind lifts the snow from the ground, creating a whiteout condition. That can reduce visibility to almost zero. Dust storms and sandstorms, common in arid regions, can also obscure visibility quickly and pose a serious hazard to both aircraft engines and their pilots' health. Obscurations in general are weather phenomenon that are obscuring the visibility. They include fog, mist, haze, smoke, volcanic ash, and blowing snow and dust. Each of these can reduce the distance you can see clearly, making it difficult to navigate. It is crucial to understand how these different elements form and affect your flight path to ensure that you can take appropriate actions to maintain safety. Understanding these weather phenomenon is essential for safe flying. Always check with weather reports and be prepared to adjust your plans to accommodate the changing conditions. Stay informed, stay safe, and keep flying smart. All right, folks, if you've made it this far without dozing off, very impressive. Tip of the cap. Now that you're officially a helicopter nerd like me, why not take the next step? Check out my online helicopter ground school at 3gheliprep.com. Trust me, it'll only get more exciting from here, or at least more useful.